Today we will discuss the topic forward versus backward chaining. Right. Earlier we have studied expert system or rule-based system. In that we know there are four main components. One is user interface, another is inference engine, and third is knowledge base. User interface is used for the interaction with the system through which we can send our query. Inference engine will intercept your query and try to find the data from the knowledge base. Right. All these data that exist in knowledge base is used to map your query, and processing is done in working memory area. In any execution cycle there are three main phases: match, select and execute. As soon as we pass our query through user interface, inference and strategies or inference engine will check the data from the knowledge base and try to find a match with your query. If there is any solution found, then it will return with your solution. Then inference engine use two types of method. First is forward chaining, another is backward chaining. In any execution cycle, these three phases work like in match phase. If more than one rule we are getting from the knowledge base, then the inference strategy will match your query. Strategy will match your query with the knowledge base facts and try to resolve the conflict among the facts. If more than one rules are matching, in that case. Then finally selection is done after resolution of conflict, which rule is fired so that we can get the result, and then final execution of that rule is done. Now, the inference strategies used in such expert system or rule-based systems are forward chaining and backward chaining. I will tell this with the help of example. Forward chaining is basically forward chaining is trying to find a then clause if there is an existence of if clause. For an example, like there are multiple rules, and if part is getting, and if we get from any rule if part is true, then clause will be true. On that concept forward chaining is based. Means start from the data and try to find your goal. This process is continue until we are not getting our goal. Right. For an example, suppose we have initial data set that contain A, B, C and G, and there are three rules that exist in your knowledge base. What are the rules? If A is true and B is true and C is true, then we can generate D. Similarly, rule 2, if D is true and G is true, then we can find the P. And third rule is, if P is true and B is true, then Q is true, and that is your goal. Now, how we can process that according to the forward chaining? What we get the initial facts? The initial facts are these: A, B, C and G. Now, after applying first rule, A and B and C, all these are existence, so that we can generate D. Means a new fact is calculated from knowledge base through inference engine, and after applying rule 1, we will get a new fact that is also stored in your or maintained in your knowledge base. Other than that, next rule is D and G. If both the parts are true, then we will get P. Means if clause is true, then we will get the right hand side part or then clause. Now basic fact D we have already generated from the execution of R1, and G is already in given facts. Then we can generate a new fact P. Now after applying third rule, P is generated fact, B is already in my data set, then both the parts are true, then we will get our goal node, that is called Q. So as soon as we get the goal, the system inference engine strategies will finalize your objective and return your solution. Working memory is basically the current that store your current fact and the facts that are generated after applying the rules. And finally, these generated facts are also maintained in your knowledge base so that further queries can be resolved. These are the new facts basically. In forward chaining, rules are fired and new data is added to the knowledge base. So this strategy is based on if-then clause. Means if part is true, then the right hand side part will also be true. This strategy is mainly used in CLIPS and some other expert systems like automated theorem provers, etc. This forward chaining starts from the data that you already have and approach to find out the goal. But what about backward chaining? Backward chaining always start from goal, and means if we have, as you know, that if then clause, if we have right hand side part is true, then how this is true? This is true based on the facts if clause. Then that's why backward chaining starts from the then clause and try to find the if clause. Now, suppose in previous example our goal is to achieve the Q. We have started from the Q. We are taking same example for the explanation of backward chaining. We have started from the same goal node Q. How we have achieved this? This then clause is true on behalf of P and B, or you can say on the behalf of rule R3. Then from this node, if we apply R3, then what are the sub goals? We have started from the goal node and trying to find the if part. Now Q is generated from the basic fact B and a node P, where P is a sub problem, or you can say a sub goal. B is proved just because it is already existing in your data set. Now after applying R3, we get a sub goal and a basic fact that is already proved. Now we have to prove our sub goal. Sub goal P. This is in then clause. Then how this is generated? From where it occurs? P is generated from the D and G. That is your if clause. Then this problem or this sub goal after applying R2 can be divided into or can be generated from the basic fact G or sub goal D. Or sub goal D, where G is your existing facts and D is your sub problem. Now again try to solve D. This then clause is coming from the basic facts A, B and C. Then if we apply R1 here, then we will get the basic facts A, B and C that is already existing in your data set A, B, C, and these are already proved, you can say. Hence backward chaining start from the goal node and try to find the basic fact that already exist in your data set, or try to find a sub goal through which we can generate basic facts. Means it's just a reverse process of forward chaining. Yeah. Forward chaining start from the raw facts or data set and try to achieve the goal. There may be an issue of dead ends in case of forward chaining that can be resolved with the help of backtracking. But in case of backward chaining, we already start from the goal node and try to find the basic facts that are given in your data set, or maybe in form of sub problems that we can solve with the help of data set. This is a base behind the backward chaining. Some programming languages like Prolog and some other systems use the backward chaining process. That's all about forward versus backward chaining.